of the independent variables. So generally, linear regression, the output is the linear combination of the independent input variables. Simply put, okay, this sentence right here. So the only difference with multivariable linear regression is that there is more variables. Single input, the single variable linear regression was saying it is just one variable x. Now the multivariable, we can see that there's x1, x2, very many x's, xn, you see? We represent the multivariable linear regression model as below. So this is just the line, the linear combination of the independent variables. So when you combine all these input variables linearly, that is what is going to give you your dependent variable. So this is basically what the linear regression is. So in which B is the bias. So we're going to look at bias later in how to evaluate your model. So there are crucial points about linear regression. Linear regression is fast and easy to implement. Like we said, it is very basic. You have input independent variables, which are the input features, and then you just do a linear combination of them, and that is what is going to give you your dependent variable, which is the output variable. Just basically drawing a line that best suits your data. So that's why they say linear regression is very fast and easy to implement. So despite its simplicity, linear regression is very effective if we are not dealing with complex data. Like I said earlier, usually if things are not very complex, go with the simple models. Sometimes they just do the job. So linear regression cannot also handle outliers. So these are just some to knows, okay? So so here we've seen that this is a regression. There are other kinds of regression like we've seen above. Where are they? Yeah. So the other kinds of regression, we've just looked at linear regression right now. There's polynomial regression, there's ridge regression, there's lasso regression. So I would advise that you actually go further and know, okay, so linear regression just draws a line of best fit between the independent variables, which are the input variables, which are the features really, and then that linear combination of those independent variables is the dependent, is equal to the dependent variable. Determines the quantity of the dependent variable. That is important because we're dealing with supervised learning, okay? So you can go further and then see now linear regression, what is its different pros and cons, and then when do we want to, like we said here, if data is not too complex, you want to use linear regression, then now the other kinds of regression, logistic, polynomial, ridge, lasso, that would be an extensive study of like, okay, when do we use those and what do we use those, but this is going to be a really high level and trying to introduce you to these concepts, and then yeah, you can build on them. All right, so now that was regression, where we were saying that we're trying to determine a numerical or continuous variable. For classification, we're trying to predict, the output of our prediction should be like a category, okay? So classification refers to a situation where the desired action is to predict the output category, such as this is an elephant, this is a flower, or you can say yes or no. That's a binary classification. Binary classification is because they're just two, based on some known categories. So a classification model tries to describe or categorize some observed data. The classification is the task of building a mapping function from the input x to the output variables y, which is categorical. So like in regression, we looked at linear regression, which was just doing a linear combination of the independent variables to determine the quantity of the dependent variable. So what we're doing in classification, what the algorithm does is it builds a mapping function from the input, which is x, the input variables, the independent variables, to the output variables, y, and the output variables are categorical. In this example, we can see that our classification model should look at this picture and say, is this a panda, is this a lion, or it's a cat? So if it is accurate and the model is very good, it will say it is a panda. So as you can see that it is a panda. Okay, so consider a classification model that wants to determine the category of an image. Since there are only 3 possible or known categories, the model will choose one of them as a prediction. In some cases, the unknown category may be considered when the model cannot make a decision. Okay, so these are the different kinds of classification algorithms. So there are different types of classification algorithms. We do not dig deep into them. We briefly describe them and address their notion. Like we said, so this blog has just introduced regression, and it has given you an example of linear regression, and this is really still very high level. We've not gone into the math of or the statistics of it all. This is just a really high level introduction. Okay, so the classification algorithms, the first example will be a logistic regression. So as you can see, this is logistic regression, and yet we're talking about classification algorithms. So you can see the name can often be confusing. It's a regression, and we already finished regression, but it's a first example of a classification algorithm. So let's look at what the logistic regression is about. So logistic regression is a method for binary classification. So for starters, I've just told you directly, logistic regression is a method for binary classification. So binary classification is like 2 categories for the output. Is it a yes or no? Is it a panda? Or is it a lion? Is it, you see? So it's not multi-category classification. It is for binary classification. It works to divide points in a data set into 2 distinct classes or categories. So for simplicity, let's call them class A and class B. The model will give us the probability that a given point belongs to category B. If it's lower than 50%, then we classify it in category A. Otherwise, it falls in category B. So this is just a high-level explanation of how this model really works. So for example, they say, let's call, it works to divide points in a data set into 2 distinct classes. Okay, so after you've trained a logistic regression and you're giving it a new data set, a new data point, and it's trying to see, okay, where does this data point best fit? Does it fit in class A or does it fit in class B? So what the model does is that it will give you the probability that a given data point, that this data point we're talking about belongs to category B. Okay, so it will give you the probability that it belongs to one of the categories, and if that probability is lower than 50%, then we shall classify it as category A, because if the probability of that data point being in one of the categories is very low, lower than that threshold that has been set, then it will classify it as the other category. Okay, so otherwise, if the probability of the data point being in category B in this example is higher than 50%, it will classify it as belonging to category B. Okay, it is also important to note that logistic regression is better for this purpose than linear regression with a threshold, because we should set the threshold manually, which is not very practical. It's also important to note that the logistic regression is better for this purpose than linear regression with a set threshold, because we should set this threshold manually, which is not very practical. Okay, they're just giving a comparison between the logistic regression and linear regression, and just saying that it's not very practical to always set this threshold that we talked about, the probability threshold. All right, so the logistic regression will instead create a sort of an S-curve using the sigmoid function, which will also help show certainty since the output of the logistic regression is not just a 1 or a 0. Okay, here the standard logistic function, note that the output is always below 0 and 1, but it never reaches either of those values. Okay, so so they have a data set here which has studying, and then saying studying, within studying there's a number of hours you're studying, and then whether you're focused or not. And then I think they want to predict success. Are you going to pass? And is it it's a true or false? So logistic regression is great for situations where you need to classify two categories, such as identification of spam or not spam emails. Okay, so this is just a high level, very, very high level explanation of logistic regression. I would really advise that you delve deeper into the reading material. I can always share more resources about this to see like how it really works, and the model details, and when it's classifying what processes does it go through, these probabilities, the thresholds, the sort curve. So I'm not going to delve deep into that, but for now what we can know is that the logistic regression is a model, is a method for binary classification. Very simply put, okay? And it is great for situations where you need to classify between two different categories. Okay, so that is the first classification algorithm. And remember, classification is when you want the output to be, when the output you're trying to predict is categorical. It falls into two different categories or more categories. Okay, so like we've seen, logistic regression is basically for the binary classification. So then there is naive Bayes, and then we're going to talk about this and we see how it operates. So a recurring problem in machine learning is we need to classify the input into some pre-existing class. Consider the following example. Say we want to classify a random piece of fruit we found lying around. Okay, in this example we have three existing fruit categories: the apple, blueberry, and a coconut. Each of these fruits have three features we care about: the size, the weight, and the color. We show the information in the figure below. Okay, so we have an apple, we have three existing fruits categories: apple, blueberry, or coconut. And then for those three fruits, we have their features: size, weight, and color. We say, okay, the size of an apple is this, the weight is that, the color is red, the blueberry is all of that. And then now we have a fruit we have lying around, and we want to say, okay, what is this fruit that we found? Is it an apple? Is it a blueberry? Is it a coconut? And we're going to base on the size, the weight, and the color. Okay, we observe the piece of fruit we found and determine that it is a moderate size. Okay, it is heavy. Moderate size, so remember size, it is heavy, and it is red. So we've said that the fruit that we want to classify as either an apple, a blueberry, or coconut happens to be of a moderate size, and it is heavy in terms of weight, and yet it is red. So one can compare these features against the features of the known classes to guess what type of fruit it is. The unknown fruit is pretty heavy like a coconut, but it shares more features with the apple class. The unknown fruit shares 2 out of 3 characteristics with the apple class, so we guess that it's an apple. We use the fact that the random fruit is moderately sized and red as an apple to make our guess. This example is a bit silly, but it highlights some fundamental points about classification problems. In these types of problems, we are comparing features of an unknown input, okay, to features of known classes in our data sets. Naive Bayes classification is one way to do this, okay? So before, remember what logistic regression was. We're like, okay, we want to classify a particular data point and to see where does it belong. Does it belong in this class or this class? Just a binary classification. Now we've seen another kind of classification where we have some random data point and we don't know what it is, but we want to classify it on based on known classes. Okay, so